New images of the spiderweb protocluster of galaxies reveal an unusually high number of active supermassive black holes. Data from the Chandra X-ray Observatory collected over 8 days show that, in the volume of surveyed space, 14 black holes at the hearts of the galaxies, including the spiderweb galaxy at the center of the protocluster, are hungrily devouring material from the space around them. This is a much higher rate than other, similar volumes of space, suggesting that up to a quarter of the most massive galaxies in the baby cluster are bound by actively growing black holes. The spiderweb protocluster, named for the spiderweb galaxy at its center, is a growing cluster of galaxies whose light has traveled 10.6 billion light-years to reach us. It hails back to a period in cosmic time known as cosmic noon, a short period approximately 2 to 3 billion years after the Big Bang in which galaxies formed stars at a furious rate. Today, wherever it is, the spiderweb cluster should have evolved into a massive, stable, gravitationally bound cluster of galaxies. Studying such clusters while they are still in the early stages of assembling should yield insights into the evolution of the large-scale structure of the universe. It can also tell us more about the processes that affect star formation rates and supermassive black hole (SMBH) activity in members of galaxy clusters. But we don't actually know how galaxy clusters evolve, so it's difficult to ascertain which groups are genuine protoclusters and which are unlikely to change. For that reason, scientists look for unusual, interesting targets displaying activity related to evolution, confirmed across multiple wavelengths. The Chandra observations of the spiderweb protocluster were part of this process. When an SMBH is actively accreting material, the process injects energy known as feedback into the galaxy around it, which in turn has a massive impact on star formation. A team of scientists led by astrophysicist Paolo Tozzi of the National Institute for Astrophysics in Italy turned the telescope onto the cluster to look for the telltale X-ray emission from feeding supermassive black holes. Although the black holes themselves give off no light, accretion is so energetic that it sends high-energy light blazing across the universe. This is what the team detected. In a region of space roughly 11.3 million light-years across, 14 of the galaxies in the protocluster were seen to be emitting X-rays, suggesting that their SMBHs are active. This is much higher than other, similar samples of space at the same epoch, with the same range of galaxy masses. Up to 25% of the most massive galaxies in the protocluster could have active supermassive black holes, the researchers found. That's 5 to 20 times higher than other samples. This could have interesting implications for our understanding of how galaxy clusters grow and affect galaxy formation and evolution. The finding suggests there is something specific to the spiderweb protocluster environment that is triggering supermassive black hole activity. It's unclear what this environmental factor might be. It's possible the gravitational interactions between the galaxies are moving material around, sweeping it towards the galactic centers where it can be devoured by the black holes. Another possibility, the researchers said, is that the protocluster has somehow retained a large quantity of cold gas, which would be easier for the black holes to accrete than the hot gas we see in nearby galaxy clusters. Or maybe a combination of factors is at play. Data from instruments that can see into different wavelengths, including the Hubble Space Telescope, should help shed some light, on this mystery, the researchers said. By exploiting the available multi-wavelength dataset on the spiderweb field, we plan to further explore the properties of the X-ray protocluster members to investigate the main physical mechanism responsible for triggering the X-ray emission, they wrote in their paper. Image credit, X-ray, NASA/CXC/INAF/P. Tozzi et al., Optical, Subaru NAOJ/NINS, Optical, HST NASA/STScI.